Thanks for being here, everybody. My name is Aaron Talwar. I'm the project manager for Design Build Senior Project Mixed Use Facility. Our project was to do a design build project of a student success and health center. The goal of the health center being to retrofit current campus facilities, and the student success center to provide new facilities to students, including study areas, advising offices, and so speak a little bit to our presentation structure. I'll cover introductions and previous experiences for our team. We'll talk about our proposed design. We are a design build firm, so we'll detail some of the intricacies of our design and what sets us apart and why we made some of our design choices. We'll speak a little bit to our sustainability goals, and then we'll cover our estimation, schedule, safety, project execution, and logistics. I'll detail our team for you guys. So as I already introduced myself, I'm Aaron Talwar. I'm the project manager for our team. We have a lot of friendly faces up here. Each of our team members was responsible for a particular part of our design and construction, but most notably Joshua Salvador and Nada Hashmi acting as design manager and construction manager. They gave our project a lot of structure and helped keep things together. So the rest of my team's up there. I won't name them all because there's quite a few, but each of them also had an important role in our project. But moving on, I'll give Josh the floor here and he'll speak a little bit about design.
Alright, for this project, we incorporated a design build process. So this project is a new 95 square foot student success and health center expansion. For this project, we did not include the demolition of the current health center. However, we incorporated a new health center as a theoretical component for it. So for this project, we also included 2 levels of parking that will provide approximately about 380 parking spaces. And this project is designed to bring students focusing services into one centralized location. Currently, right now, we have the library and the Bronco Student Center. But with this project, we're hoping to expand that and also expand the different areas of academic support, wellness, and collaboration to the campus day-to-day life. Overall, roughly, our project runs about a 174,000 square footage. Within the area, it also has an outdoor seating area and areas where students can be active on campus and different pathways to the different infrastructures, mainly near Building 1 and the College of Engineering. As you can see here, we have a couple of our renderings for the project, showcasing the different outside environments and different elements that we incorporated within this project. I'll now leave it to our different design components and different design leads to talk about the aspects of our project.
Make sure you introduce yourself when you come up.
Hello everyone, I'm Diego Diaz, the civil design lead for our project, and I'll be presenting the site analysis and grading approach for the project. So we initially started off by coordinating as a team with faculty in order to receive any type of information like plans or designs that currently are existing for this area or that overlap it. One of the initial tasks was to verify the drawing, make sure it was within scale, and also check any datums, so any existing control, whether that's horizontal or vertical. And then we continued by creating a topographic survey of the area with the as close to accurate as possible of the existing surface that we had to work with. Initially, we noticed pretty quickly that there was a grading issue, that a lot of the terrain was bowl-like shape, pushing any stormwater into the middle of the site. So for that, we approached the grading plan to work with that to limit the amount of soil that we had to fill, and we created some trench drains that would allow the water to flow in, but collect it before it reached any occupancy issues. Lastly, we reviewed the stormwater protection, pollution prevention, in order to design according to code compliance, and that's all I have for now.
Hello everyone, my name is Isaac. I am the civil lead for plumbing. For our civil utilities, we began by identifying and verifying all underground infrastructure. We did this by requesting as-built drawings from CDB. Coordination with 811 dig alert is also critical to ensure safety during excavation. We want to minimize damaging any of the existing utilities. Our utilities are pretty old. Some can exceed 10 years plus. Our design includes tie-ins to existing manholes and street connections. Yeah, so our proposed connection type is through the manhole or street connections. We did account for an existing abandoned water line, which is located right within the footprint of the Student Health Center building. All the utilities are within or less than 500 linear feet. For our demolition, our approach focused on site preparation rather than removal of any structures, since there was no existing buildings on our site. We developed a strategic demolition plan centered on clearing the new building footprints for construction. Primarily, all our demolition is consisted of citrus orchards and vegetation. As you can see in this image here, this was taken looking south. We have a dense vegetation of citrus trees. In this aerial photo, we have the red line demonstrates our project boundary.
Can I jump in one second?
Yeah.
I think if you could tell a little bit of the story of, we have this massive field of orchards, and it's a real tough task to preserve all these trees, and part of our challenge is that we're gonna have to grub all of this, and then we're gonna safely move it to another site so that we can preserve, give it a little bit of a story to it.
Okay. It probably also helped to add like the footprints of like where the buildings are gonna be. Just show like.
Aaron, would that be more on the construction side though?
Was there?
Would that be more on the construction side? Kind of our approach on how we're doing, you just identify.
Yeah, but even then, I think for the civil utilities as well, tell a little bit of that story about, what you found tough about that your assignment.
Okay. That's pretty much all I have.
Thanks.
Hi, my name is Captain. So for our building, we wanted to cater for extra use of space for the different colleges here on campus in order to support the students' academic safety and growth. Our first floor is primarily composed of some offices, event rooms, and cafe areas where students can come together and collaborate. You can go on to the second floor, please. And the second floor is mainly composed of various rooms where they can be reserved online in advance. And it just allows for, again, extra space where students are able to study, get together, and make perfect use of their time to do any work. And this floor is the central open workspace to also encourage the interactions between students. And there are also quiet rooms for any student that just needs to wind down or relax if they need to.
I'm Kevin, I'm the electrical lead, and for our third floor the Success Center, the design was centered around a more dedicated study center environment. It has a mostly open layout, and it allows for a high student capacity while maintaining a clear and organized space. The seating is arranged in a way that supports both individual work and group collaboration, instead of trying to serve too many different functions. You'll also notice that the loungers are integrated throughout the floor. These spaces give students a place to take breaks or have more informal discussions, which helps balance productivity with comfort. Overall, the design focuses on simplicity and efficiency, making it easy for students to navigate and use the space during peak hours.
Okay, so as we segue into the visualization highlights, what you're going to see here is that every decision that we made reflects efficiency, safety, and long-term value for the campus here at Cal Poly Pomona. The main entrance is going to be located along Mansion Lane, and this provides a clear and controlled access to our site. We then placed our garage below grade to reduce the visual and spatial impact on the overall campus and maintain the flow of the campus, while also taking the aesthetic of the actual building into account as well. This layout promotes efficient vehicular circulation with intuitive wayfinding, which makes it easier for students and anyone going in and out of this facility. We also incorporated our mechanical ventilation and life safety systems, specifically sized for the below grade environment. And then by our underground parking structure, we preserve the surface level spacing for landscaping and everything that's coming above grade for our actual Student Success Center. Overall, this design will support long-term campus growth and maintain the flexibility of the future use with structural integrity.
So moving on to the electrical design portion, the goal here is to provide a reliable and consistent power distribution across all floors of the building. The load calculations are based on expected occupancy, lighting demand, and the equipment used within the study and collaborative spaces. The system is centered around a main switchboard located near the electrical room on the top right, which allows for more efficient and centralized control. From there, distribution panels are placed throughout each floor to supply power to lighting receptacles. Branch circuits are then used to serve specific areas like study spaces, lounges, and offices. A key feature of the building is the LED lighting throughout the building. This improves visibility and overall comfort for occupants, which also reduces energy consumption and long-term operating costs.
Hi, I'm Aryan, the mechanical design lead. So looking at the overall significance of the HVAC system in our building, it really goes beyond just heating and cooling. The HVAC system is responsible for maintaining a comfortable indoor environment by controlling things such as the temperature, airflow, and humidity within the building. This is important not just for comfort, but also for occupant health and productivity, especially in buildings with a higher occupancy such as our Student Success Center. Another key role of the HVAC system is to ensure proper ventilation and airflow distribution within the building by continuously supplying fresh air and removing contaminants within the system. It helps create a safer and healthier environment. In some cases, HVAC systems also are responsible for controlling pressure differences within different rooms, which is critical in specialized buildings such as our health center. From an engineering perspective, an HVAC system makes up a large portion of a building's total energy consumption. So an efficient design layout directly impacts operating costs and sustainability. Proper duct layout and airflow distribution are also important to make sure conditions are consistent throughout the entire building. Now when we bring SCADA into the system, we are enhancing how the HVAC system operates. SCADA allows us to monitor and control the system in real time by collecting data through sensors for things such as the temperature, pressure, and airflow. This data is all collected and sent to a central interface where operators can observe how exactly the system is performing at that given time. Using this information, the system can automatically make adjustments to things such as the temperature, or airflow based on the demand, which improves efficiency and reduces energy waste. SCADA can also help with maintenance, as it can detect faults early and trigger alarms, which can prevent larger scale systems failing. Overall, integrating SCADA transforms a traditional HVAC system into a smarter, more efficient system that improves performance, reliability, and long-term operation of the building.
I'm Sarah, the lead estimator, and alongside with my team, we came up with an estimate for both the Student Success Center and the Health Center. A total contract value of $111.9 million. That ends up as $718 per square foot. For our largest contributor, we have the B10 superstructure within our estimate, and that component is at $31 million due to the shear walls that we incorporated into our plans. Alongside that, we have foundation, site work, electrical, and HVAC. Both the SSC and the Health Center have separate foundations, which consist of a slab-on-grade systems constructed with 5,000 PSI concrete, and that takes up a good amount of our estimate with over $600,000. After the superstructure, we have, I want to get rid of that, sorry. Besides the logistical aspect of the estimate, we also want to ensure the space is both aesthetically pleasing and comfortable for students, and our goal is to maximize the space we use to provide. So some of our estimate did go towards little aspects like that. You can see in the renderings as followed towards the end of the slides.
All right, now I'll share some of the figures of this project with you guys. As Sarah addressed, she touched on some of our costs, especially with the shear wall in the basement of the parking garage. But just to look at some of these figures, $31 million for the superstructure, as well as all the separate costs for electrical and exterior enclosures, and some comparisons for gross square foot per dollar, sitting around what's typically standard at about $700 per gross square foot, especially for a project of this sort. Hard cost for construction is about $89 million, and total cost is about $114 million, considering all of our indirect costs, including bonds, owner contingencies, design fees, etc. All right, I'll speak for Mario. Schedule.
Yeah, I think we're gonna have to change this slide for sure.
Yeah. Are you Muslim?
No, I'm.
He's gonna go into inspections
Yeah.
after with overall.
After this,
But it's gonna be on that
it's
slide.
gonna be on that side, so. Hey everyone, my name's Josue and I'm the field engineer on this project, and I was in charge of the inspections. And so for this project, we made a separate schedule for all of our inspections, starting with the foundation, then going into all the concrete inspections, which should include decks, columns, and major slab on grade pours. Then we would go into all our MEP systems, rough-in, framing, and then finally with our roof inspections. And we'll show it on here just to give an idea. Our final inspection though would be for certificate of occupation, which would be August 22, 2020.
Hello, I'm Christopher Calderon. I was tasked with creating an emergency route plan for our project. Safety is our primary objective on this project, so we must always be prepared for the worst. This slide outlines our emergency route plan from our site location to the 3 nearest critical response centers. For immediate security or initial medical response, our primary point of contact is the CPP Police Department. In the event of a fire, entrapment, or need for a specialized rescue, the designated contact is the LA County Fire Station 187. And for serious injuries requiring a medical facility, the Pomona Valley Hospital Medical Center is the closest full-service trauma center.
provide some visual a little bit, but.
I can make it better.
Hello everyone, I'm Luis Mendoza. So I was in charge of kind of doing the site-specific safety plan. So now transitioning to our safety project execution and the logistics portion of the project for our Student Success Center expansion, we developed a site-specific safety plan that aligns with the scale and the complexity of our design, including our parking, our excavation, and vertical construction. Our key objective is obviously our safety as poly builders, is to achieve zero OSHA recordable injuries, maintaining 100% PPE compliance, and hold weekly safety meetings to keep all crews aligned and proactive throughout each phase of construction. To support the goals, we've implemented targets such as safety programs, for example, fall protection and from work above, excavation safety protocols, silica exposure controls, and heat illness prevention, which is something big that's out here in Pomona, which is specifically important to given to this project's location and working conditions. Based on our construction scope and phasing, we identified several high-risk activities, including excavation cave-ins, crane operations, fall hazards, and heavy equipment use, all which are critical during site work and structural operation. To mitigate these risks, we've enforced strict controls such as proper PPE, guardrail systems, use of certified operators, and clearly defined exclusion zones. And these are just a couple of so many that we could mention. This is also while ensuring full compliance with OSHA and Cal-OSHA standards. Overall, this safety plan is integrated in our execution strategies to ensure every phase of our construction is completed safely, efficiently, and without any incidents.
Hello everybody, my name is David Flores and I was the main site utilization lead. Starting with our overall site logistics plan, the project is accessed primarily from Mansion Lane, which serves as our main entry and exit for construction traffic. This allows us to avoid disrupting the higher traffic along University Drive. We've established a controlled site with designated access gates, a job site trailer, worker parking, and a material laydown area across the street to keep the main site open and efficient. During mobilization, we begin with site clearing and preparation, including installing fencing, setting up site facilities, and establishing haul routes for trucks and equipment. From there, we transition directly into excavation. In phase 1, excavation begins at the Student Success Center using a temporary haul ramp, allowing trucks to enter the excavation and be loaded directly by excavators. This is the most efficient phase for the soil export. As we move into phase 2 and excavation reaches deeper levels, trucks can no longer safely enter the excavation. We transition to a top loading operation where excavators at the bottom cast soil up to a loading platform and trucks are loaded from above, improving safety while maintaining productivity. Once the SSC excavation is complete, phase 3 shifts operations to the health center. The same haul routes and access points are maintained, allowing for a smooth transition without reconfiguring the site. This phased approach controls site congestion, avoids operational conflicts, and keeps construction progressing efficiently across both building areas.
Each phase builds on the last, keeping the campus safe, the site efficient, and the schedule on track. We start with phase 4, where the foundation and underground parking for the Student Success Gateway come to life. The permanent laydown yard drives the flow of materials and controlled haul routes to keep the life campus moving safely and efficiently. With the cranes set and excavation complete, crews move through a steady flow of forming, pouring, and curing, establishing the structural base that the rest of the project depends on. Moving on to phase 5 is where the health center's concrete structure rises into two separate segments. Breaking south to north, each section is poured and cured and stripped before advancing, keeping the same access points and haul routes maintains predictability on the busy campus while ensuring quality and safety as the building footprints take shape. Phase 6 brings most of the visible transformation. The elevated slabs of the Student Success Center, level by level, the structure climbs up through a cycle of forming, reinforcing, pouring, and curing. The crane, scaffolding, and shoring systems work in sync, supported by the consistent communication from the GC's office, and the muster point as a vertical construction becomes the project's main focus. Finally, looking at phase 7, the work shifts from the structure to an experience. Site concrete to paving, ramps, and landscape features tie the building together into the campus. As major lifts wrap up, the crane is removed and the site opens up for grading and finishing. Fencing and pathways adjust as areas reach completion, gradually transforming the zone from an active construction site into a welcoming campus environment.
Yeah, this one. Hi, my name is Justin Stang. Since this project is on a considerable slope, we formatted a SWPP map to redirect high levels of water flow using silt fencing, inlet protection, and sandbags. We will have a mobile crane on site with a radius of 80 meters, allowing for 2 different locations, depending on the point at which we are at. For phase 1 and 6, it will be at location 1 and will be used, and for phase 5, it will be at the second location. As for the utilities, such as power and water, we will be using temporary lines closely towards the point at which we already have it decided at the proposed location. There will be 2 temporary transformers. They both have a 3-phase 280 volt to 240 volt over 120. There should be plenty of power to support task lighting, spider boxes, and pretty much any other heavy equipment that's required. There'll be 2 different haul routes, one from the 10 freeway and one coming from University Drive. This will limit traffic and allow for better delivery methods, considering their laydown area will be across the street. Also, this will help reduce traffic from campus since it will be used throughout the whole project.
So here at Poly Builders, you're not just getting a construction project, you're getting an experience. This is why we've implemented Cal Poly Pomona's motto right on the front face of your building. We've given ample space outside of your building, plenty of space for us to enjoy the scenery with outdoor seating, covered patios, outdoor water fountain. Hitting our LEED and sustainability goals, we have our 2-story underground parking structure to ensure there's enough flow and people can park in spaces to use this facility. We have our inviting space, our cafes and our study rooms broken into separate colleges to ensure collaboration amongst colleges, quiet study spaces and meditation rooms. And then we go into our health center. Health center will be to look out for the students and shit like that, stuff like that. And again, thank you for trusting us with this project, and yeah, go get Poly Builders.
And I'll give a little sign off here. So I think the one thing that I want to work on, and especially creating the narrative, is what story are we telling? And I also think we need to work on integration as a firm. We talk about our brand as Poly Builders as well. So that's one thing that I'll try and cover in the introduction. But really, we feel like a design firm and a team together. And then for design specifically, also a little bit more of a story about what do we want to highlight about this building's design? Why is it important? What features are really important to us?
To add on to that, can you send me the video?
Yeah.
I'm gonna try to look at each part of design and see if there's anything else that we could do that stand out or innovative.